multiplication and division of decimal numbers is done the same way as decimal numbers without the decimal point. There's an additional step when you're doing it by hand that you have to take into consideration. You'll see that I have written multiplication with this dot here. The dot notation for multiplication is much better when you're doing algebra, because x is commonly used as a variable, and the x with the multiplication sign can get confusing. So I recommend moving to the dot notation whenever you're talking about multiplication. Make sure you put it in the center and you don't confuse it with the decimal point, which is lower down and only by numbers. So just make sure you understand how to use the dot notation. But here we have this first problem is 0.12 times 0.6. Now we don't have to line anything up when we're doing this by hand. We can kind of ignore the decimal point for the first part. What we're going to do is we're going to actually do the 6 times 2 is 12. Add the 1 up here. 6 times 1 is 6 plus 1 is 7. And then of course the zeros, there's no point in doing the zeros, so we can stop there. The last part, the additional part, when you do multiplication division, is you need to count how many decimal places to put in the end. And that you just start on the end of each number. You go 1, 2 places that's been moved here, and then there's 1 additional place. So 2 places in the first plus 1 place in the second, that's 3 places total. Put the decimal point at the very end of the number on the bottom and move it 1, 2, 3. Any place that's missing, I drew the second place quite large, but just add a 0 if you're missing a place. Then always add a 0 in front of the decimal point. So it's going to be 0.072. Now, we're not done yet because the rest of the problem says round to 2 places. The most important thing about rounding is that you understand what place you're talking about. In this case, it says 2 places, and that means 2 places after the decimal point. But you could have, for instance, in the second problem here, it says round to the 10th place. The 10th place is 1 place past the decimal point. But for our problem, we're going 2 places past the decimal point. So we have 1, 2. So we're rounding to this place, meaning our final answer will have a number in that place and nothing to the right of it. To round, all you have to do is look at the next number. If this is 5, let me write it like this. If this is 5 plus, we add 1. And then less than 5, let's say 0 to 4, we do nothing. In this case, this is 2, so we're not going to do anything to the 7. If it was 5 or greater, we would add 1 to 7. But we're not going to do anything to 7 because we have 2 in the next place. So we just drop it and write the number out. 0.07 is the number that's rounded to 2 places. And you see we have 2 places past the decimal point. So we have rounded it correctly. Next one, 31.002 times 9. 9 times 2 is 18. 9 times 0 is 0, plus 1 is 1. 9 times 0 is 0. 9 times 1 is 9, and 9 times 3 is 27. You can put the 7 down there, put the 2 up there. You can think there's a 0 here. 9 times 0 is 0 plus 2. Or you can just drop down to 27. Now we count how many places the decimal has moved. We have 1, 2, 3 places. And here, there is no movement, which means the decimal has moved 0 places. So we really only need 3 places for the final answer because of the 3 places here and there's 0 there. We have 1, 2, 3. Decimal goes right there. So we get 279.018. and it says rounded to the 10th place. The first place after the decimal is the 10th place, so we're rounding to the 0. So we look at the next number. Is the 1 5 or greater? No. So we do nothing, and we just drop the 1 and everything after it. We have 279.0. This is rounded to the 10th place because the 10th, there is a number in the 10th place. Now it's 0, we still write it because we're rounding to that place. It's kind of an idea for error measurements. So make sure you write it even though it's 0. But that's how we round to that place. Let's keep moving on. So we have 0.63 times 100. Now first off, you may notice that there's no rounded there, which means we just leave the answer as it is. We're not doing any kind of rounding. The second thing in here is that this problem is unique in that we're multiplying by a power of 10. Whenever you multiply or divide by a power of 10, this is actually quite simple to do in our number system because it is base 10. 100 has 2 zeros in it. So all we have to do, because we're multiplying, is move the decimal 2 places. Right, 100 is a big number, so if we multiply by 100, the number gets bigger. So we go from 0.63 to 63, which is the decimal points there. All I've done is I've moved the decimal point as many times as there are zeros in the power of 10, be it if it's 100, it's 2 times. If it's 1,000, there's 3 zeros. So 1,000 has 1, 2, 3 zeros, so it's 3 times. If it's 1,000,000, there's 1, 2, 3, 4, 5, 6 zeros, so you move it 6 times. That's only if you're multiplying by this number. If you're dividing by it, it moves the other way that many times. I'll show you that later. Okay, so 63 is our answer. There was no rounding, so we didn't have to worry about any of that kind of stuff. Okay, the next one. Let's move down here. A little more space here. All right, 0.0085 times 0.044. 4 times 5 is 20. 4 times 8 is 32. Plus 2 is 34. 4 times 0 is 0 plus 3. We cancel all those things out, add the 0. 4 times 5 is 20. 4 times 8 is 32. Plus 2 is 34. 4 times 0 is 0. Plus 3 is 3. And then there's the rest are just 0, so there's no point in continuing that. And then we add 0, 4, 7, 3. This is just like how you'd normally multiply whole numbers. Make sure you add the 0. When you cancel, make sure you add a 0. That kind of stuff. Okay, now we can ask the question, how many, or where's the decimal point? So we start in the top one, count 1, 2, 3, 4 places. Bottom one is 1, 2, 3 places. 4 plus 3 is 7. So we're going to move the final answer 7 places. There's 4, 5, 6, 7. We need to add some zeros. The decimal goes right there. So we have 0.000374. This is with no rounding. With rounding to the 2 places, we're looking at 1, 2 places. And so this, we look at the number next to it. Is this 5 or greater? It is not. So we do nothing to it. So we don't add 1 or anything. We just cancel off the rest of it. So 0.00. This is to 2 places. And then to the thousands place, We have the tenths, hundredths, thousandths. You look at the next one. Is this 5 or greater? It's not. So we just kind of cancel it. We don't worry about doing anything else to it. And we have the thousandths place, or 3 places. Now, 2 places and thousandths place, these are actually the same number. It's just 0. Of course, it's not. When you do no rounding, you see there are numbers there, 3, 7, and 4. But if your error measurement is only as good as it is to 2 places, effectively this number would be 0. That's why rounding is important when you're looking at a lot of times error measurements, statistics uses these kind of things, these ideas. All right. 702 times 3.19. 9 times 2 is 18. Times 0 is 0 plus 1. 9 times 7 is 63. And that 6 just gets brought down. Then we remove the 9, add a 0. 1 times 2 is 2. 1 times 0 is 0. And 1 times 7 is 7. Cancel that. Add 2 zeros now because we're 2 places in. 3 times 2 is 6. 3 times 0 is 0. 3 times 7 is 21. Add a 2, but that 2 just gets brought down. And now we add 8, 3, this is going to be 9. 6 plus 7 is 13. We're going to bring up the 1. 1 plus 1 is 2, and a 2. Finally, this has no decimal places because there's no decimal point showing. This one has 2 places. So 0 plus 2 is 2. Move it 2 places. And we get 2239.38. This says rounded to the hundredths place. This is tenths, hundredths. There is no number next to it. So that means it is already in the hundredths place. So it is fine by itself. Okay. So this last one here, this looks like a long, kind of drawn out number here. So I would suggest just using a calculator. I think it's going to be too much prone to error to do by hand. 0.18. And when you multiply these numbers, we get 0.11208618. Okay, it says rounded to the 10,000ths place. So this is tenths, hundredths, thousandths, 10,000ths right here. So we're going to look at the next number. Is this 5 or greater? It is. So we're going to add 1 to that number and then cancel everything else. That gives us 0.1121 because 0 plus 1 is 1. And that is our rounded number to the 10,000ths place. So that's multiplication. Division works the same as you do with the decimal numbers. We can do it, by longhand. And then we ask, how many times can 9 go into 2? It cannot. How many times can 9 go into 21? That can go in there twice. 2 times 9 is 18. And subtract. 21 minus 18 is 3. Bring down the next number. How many times can 9 go into 31? It can go in there 3 times. 3 times 9 is 27. Bring down the next number. How many times can 9 go into 45? It can go in there 5 times. 9 times 5 is 45. And we get a remainder of 0. We also bring this decimal number straight up. And you see we get 23.5. So it works the same way as your regular division. Just make sure you're handling the decimal number. Like at the very end, you bring it straight up. There is a caveat, and that is if there's a decimal number in the divisor, as there is in the next problem. Let me just bring this one over here. Writing this in long division hand, or notation, I should say. The first step is to move the decimal in the divisor all the way over. However many spaces you need to move it, count those many spaces. So in this case, we moved it one space. We need to do the same thing to the number on the inside. This will end up going to the top right here. That's why it's important to move the decimal points first. Then you can bring it up and just divide as you normally would. I'm going to get rid of these arrows just to make it a little bit cleaner to look at. All right, now how many times can 2, right, this divisor here is just the number 2. How many times can 2 go into 0? 0 times. How many times can 2 go into 3? Once. Bring down the next number. How many times can 2 go into 11? 5 times. 5 times 2 is 10. And now we have a remainder. So what we can do is we can always add more zeros onto the end of it. And we'll do that until we either see a terminating number, so where, like in the previous problem here, we got a 0 as the remainder. If it terminates that, then we're done. If we see a pattern, a repeating pattern, then we can stop there because we know it'll keep repeating. Or if we get sufficiently far enough to where we want, like if we're going to round to 5 places, make sure you go to like 6 or 7 places so that you can round the answer to 5 places. Okay, in this case, we only needed 1 because if we bring the 0 down, 2 can go into 10 evenly 5 times. And so we're done. So the answer is 1.55. Make sure you move, the first thing I did was I moved the decimal point 1 space, and so I moved this one space and brought it up there. If you didn't do that, the answer would be 0.155, which was incorrect. Make sure you move that decimal point if the divisor has a decimal point that's not the very right-hand side. Okay, this one's similar. Let's write it like this: 1.632 divided by 0.08. The first thing is 2 places now. 2 places. Bring it straight up here. And now we can continue with the problem. The divisor now is just the number 8. So I'll just erase that stuff to make it cleaner to look at. That's the reason why we're doing this. We're trying to make the divisor a whole number. And we do that by moving the decimal points the same number of times. We can do that because we're doing it the same number for both numbers. Okay. How many times can 8 go into 1? It cannot. How many times can 8 go into 16? Twice. Bring in the next number. How many times can 8 go into 3? It cannot. Bring in the next number. How many times can 8 go into 32? It can go in there 4 times. And that gives us 32. We have a remainder of 0. So our answer is 20.4. Now, this one is a division by 100. And like I said before, a multiplication and division by a power of 10. So 10, 100, 1,000, million, billion, trillion, all those are easier to do because our number system is base 10. So we don't have to actually do long division. We can immediately find the answer because this power of 10, 100 here, has 2 zeros. So I'm going to make this move 2 zeros to the left. What this does is it makes the number smaller, right? When we divide by a big number, the numbers always get smaller. So we should get a smaller number in the end. So our answer is 0.08709. Again, all I did is I moved it to the left, the number of zeros in the divisor. In this case, there was 2. So if it was 10, I'd move it only one space. If it was 1,000, I'd move it 3 spaces. Okay, now we need to round to the hundredths place. This is the tenths. This is the hundredths here. So we look at the next number. This is 5 or greater. So we're going to add 1 and then remove the rest of it. That gives us 0.09 as our final answer there. All right, 5 divided by 21. You see here we don't have any decimal points, but we need to make some because 21 cannot go into 5. So a number always has a decimal point in the end, right? 5 is 5.0, 21 is 21.0. So I can add that decimal point in and now ask how many times can 21 go into 50? And go in there twice. 2 times 21 is 42. Add the 0. How many times can 21 go into 80? Go in there 3 times. Give me 63. It gives me 17. 21 into 170, I would say 8 times. I should actually bring this decimal point up just to make sure we're on the same page here. 8 times 21 is 168. We get 2. 21 cannot go into 20. Bring out another one. 21 into 200. 10 times obviously is too much. That'd be 210, but it can go in there 9 times. 9 times 21 is going to be 8179, I believe. Let me check that to make sure. 189, I meant, not 179. It gives me 11. You can see how long this can take. We really only need to round it to one place, so there's really no point to continue. So I'm just going to stop there because we're rounding to one place, so that means we need to round to this 2 place. So we look at the 3, it's not 5 or greater, so we can just cancel the rest, and the answer is 0.2. Just to show you something real quick here. If we were to continue doing this, 21 can go into 110 5 times. 5 times 21 is 105. And that gives us 5. Now what's interesting about this is 5 is where we started, which means when we add a 0, 21 can go into 50 2 times. 2 times 21 is 42. But that's exactly the same thing we're doing right here, which means this is just going to happen again, and that means it's just going to happen again eventually. And we're going to get the exact same pattern. We're going to get this whole block all over again. It's going to be 2, 3, 8, 0, 9, 5. 2, 3, 8, 0, 9, 5. And it's going to continue that. We can write this out in a different pattern or in a different way. For 0, 2, 3, 8, 0, 9, 5. With a bar on top, that means it repeats the same pattern indefinitely. It's a repeating pattern. So that's kind of an interesting point. So you know you can stop there. When you start seeing this repeating pattern here, you know you don't need to continue. It's going to do this, indefinitely. At a certain point, it doesn't matter, right? We're getting down to a small enough place value to where it effectively doesn't mean anything anymore. So that's why you can just kind of stop at a certain spot, or just go till you find the rounded place that the answer requires. So for this next one, we can just do this on a calculator. 43 divided by 57 gives us 0.7543859, and it continues on. I can stop there because I need to round to 4 places. So 1, 2, 3, 4 places. We look at the next one that is 5 or greater, so we're going to add 1, and drop the rest. So we get 0.7544 as our rounded final answer. One thing that's helpful when you're working with numbers is to know how to find the average of these numbers. To do that, we need to make sure we understand how to add decimal numbers and divide by them. Really, to find the average, all you're doing is you're adding up all the numbers and dividing by how many numbers that you're adding. In this case, we have 1, 2, 3, 4, 5 numbers. So we're going to make sure we divide by 5. So to find the average, we do 6.57 plus 6.62 plus 6.39 plus 6.95 plus 6.63, all divided by 5. This really is a job for a calculator. There's not much point in doing it by hand, especially if you have many of the numbers, like hundreds of numbers. That's going to be a job for a computer. That's the whole point of having computers, is to make the tedium decrease. So I have 33.16 divided by 5. And that gives me 6.632. This number, the average, should always be within these numbers here. So 6.632, all right, the lowest number here is 6.39. And the highest number is, 6.95. So 6.632 is within the lowest and the highest. It's typically going to be around the center of it. That can be skewed around closer to the lowest, closer to the highest. Okay, for the bottom one, same idea. I'm just going to add these all up and then divide by 5 because there are 5 numbers again. Doing this gives me 0.7204. The lowest number here is, the highest number is this one. And you see that this number is somewhere around the center. Again, that may not always be the case. It might be closer, lower, or higher, depending on the number set you have. How much does 15.7 square feet of number 16 gauge steel weigh if 1 square feet weighs 2.55 pounds? So if 1 square foot weighs 2.55 and we have 15.7 square feet, and all we have to do is do 15.7 times 2.55. You can do this by hand if you want. I would use a calculator. And I get 40.035 pounds. Typically, it's best to just round to the lowest decimal point. In this case, this one has 1 decimal point. This one has 2 decimal points. So I'm going to round to 1 decimal point, which is this point here. This is not 5 or greater, so I'm just going to remove that, and I get 40.0 pounds. That's because we have only a certain accuracy of each one of our numbers. If I wanted to round to 2 decimal points, then it'd be better if this number here was 15.70. This has 2 decimal points, and that one has 2 decimal points. There's also this thing called significant figures. That's going to be a topic for a different video, but that also is really dealing with how many numbers can you have to how accurate of a measurement did you make, that kind of idea. So we're building a storage tank here, and we have a couple of costs. The first one here is this material cost. We have 208 square feet of material at 9.29 per square foot. Then we have a labor cost here of 4.5 hours at $26.40 per hour. Then we have a cheaper labor cost, 1.6 hours of labor at $19.60 per hour. The total cost of the tank is going to be all of these costs added up. So we have 208 square feet times $9.29 per square foot, plus 4.5 times $26.40. That's hours and then dollars per hour, plus 1.6 hours times $19.60 per hour. So using the calculator, we will find each one of these individual costs. So the first one here is going to be $1,932.32. That's the material cost. Then the first labor cost is going to be $118.8. The second labor cost will be $21.2. And we add these up. And since this is in dollars, we're going to round to the nearest cent. Here we have an artist drawing a rectangle using the golden ratio. If you don't know what the golden ratio is, look up the Fibonacci numbers, golden ratio, and then these things in nature. It's kind of a cool thing. But the golden ratio is just a number that's like it's 1.618, and then it continues on indefinitely. It's not a simple number. It's like pi or e, if you know that. They continue on indefinitely, and there's no repetition in them. It's called an irrational number, and it's very special. It's very pleasing to look at. So if the longer side should be the golden ratio times the shorter side, 1.618 times the shorter side, and we have a shorter side of 3.15 inches, then what's the longer side? Well, that's just going to take 3.5 inches times the golden ratio. We're just using an approximation of it, and that'll give us the length of our longer side. So doing that on a calculator gives us 5.663, and it says round to the nearest tenth. That's the 10th spot, so we look at the next one. That's going to be 6, which is 5 or greater, so we're going to add 1 and drop the rest, giving us, I should say, this is approximation, not equal to 5.7, and this is in inches. So that's the length that the longer side should be for this rectangle. So Marquette, Michigan has an average of 128.6 inches of snow per year, and that assuming that it snows 6 months of the year. If you've never been up there, that's probably pretty average, 6 months of the year, sometimes more. But if you assume 6 months of the year, then what is the average monthly amount of snow that falls during these months? So if it gets 128.6 inches of snow every year, and it snows only 6 months of the year, then all we have to do is take 128.6 and divide it by how many months it actually snows. So let's do that. I'm getting 21.43333. Repeats like that. You could say this is also equal to 21.43 repeating. And it wants us to round to the nearest tenth. That's this spot here. 3 is not 5 or greater, so we do nothing with it, and we just ignore the rest of it. So we say that it gets approximately 21.4 inches inches per month.